Hello guys, welcome to my channel. This is Ehsan and in today's video we're going to solve another IELTS reading, Cambridge IELTS Book 10, Test 4, Reading Passage 3. I've already covered the first two passages. It's better to have this book in front of you and take notes and have your pencil while watching this video. Turn off any distractors such as your cell phones to have your full concentration. I'm going to give you lots of tips and strategies to how to deal with this kind of tests. And it's better to smile and make yourself relax because this is a great practice, especially if you want to take the IELTS exam. And if you're new here, please give this video a thumbs up, hit that subscribe button and also the notification bell so whenever I upload a new video, you'll be aware of it. Okay guys, without much further ado, let's jump into it. I'm using this website startcamp.com and I'm gonna put the link in the description below. This is a great website to make yourself ready, especially if you're an IELTS candidate for computer-based exam. This is a simulation website and this is a great website to practice these IELTS tests. The title of the passage is actually When Evolution Runs Backwards. Unfortunately, this website doesn't include a title, and this is just a subtitle. Evolution isn't supposed to run backwards, yet an increasing number of examples show that it does, and that it can sometimes represent the future of a species. This is how the whole idea of the passage is about. This is a great thing to start your IELTS reading the title and subtitle if included. So get to know, get the feelings, what is it going to talk about in the passage. So this is a passage 3. Passage 3, most of the times passage 3 are the most difficult ones to answer. And actually I'm using a little bit mixture of techniques to how to deal with this kind of questions. So first, look at the questions. This is a multiple choice questions, 27 till 31. So in this type of test, the questions and answers are in the same order. This is a good news actually. For 32 till 36 is actually again, this is again the questions and answers are in the same order. This is some incomplete sentences that you have to complete it with the options from A to G. Again, 32 till 36, the questions and answers are in the same order. And for 37 till 40, yes, no, not given, again, questions and answers are in the same order. So what is going on in here? How we can deal with this type of tests? I'm going to actually highlight the keywords related to just the first question of each part, because I know that when I'm going to find the first question, then I move forward to the next question. So with that being the case, I'm having a little bit keywords on the back of my brain and then continue reading the whole passage to find the answers. So here we have 27. Question 27. When discussing the theory developed by Louis Dollo. So probably this is the most keyword here. The writer says that. Just focus on Louis Dollo. So 32. For a long time, biologists rejected what? This is another keyword to highlight, and don't read the options. When I find this question, this keyword, then I'm going to look at the options actually. For yes, no, not given, actually it is better to read the first two because maybe the first one is not given. You don't know. Sometimes it happens. So Wagner was the first person to do research on South American lizards. Wagner, South American lizards. And again, Wagner believes that Bacchia lizards with toes had toeless ancestors. Okay, guys. Now, just the keywords. Louis Dollo, biologists, Wagner, South American lizards, Wagner, Bacchia. Just these ones. With these limited keywords in your mind. Now moving forward to the passage. Go ahead and look at the passage. The description of any animal as an evolutionary throwback is controversial. For the better part of a century, most biologists have been reluctant to use those words. Biologists. Does it ring a bell? Yes, of course. For a long time, for the better part of the century, biologists rejected, reluctant to use those words, mindful of a principle of evolution that says evolution cannot run backwards. Evolution cannot run backwards. Now, look at the options. The question of how certain long-lost traits could reappear, the occurrence of a particular feature in different species, parallels drawn between behavior and appearance, the continued existence of certain genetic information, the doubts felt about the possibility of evolution being irreversible. The possibility of evolution being reversible. What does it say? Here it says that evolution cannot run backwards. Here it says that reject the possibility of evolution being reversible. Rejected of evolution being reversible means evolution cannot run backwards. Just paraphrasing the passage in here. So the answer for this question is actually option F. You have to write down F on your answer sheet or choose this one. And I'm going to actually highlight the F as well to do not look at it for the next questions. Now I had to actually read the next question and highlight the keyword related to question 33. Opposing views on evolutionary throwbacks are represented by what? Now, when I'm going back to the passage, I had to take care of opposing views, Luis Dolo, Wagner, South American lizard Bacchia. Just these vocabularies. Okay. But as more and more examples come to light and modern genetics enters the scene, that principle is having to be rewritten. Not only are evolutionary throwbacks possible, they sometimes play an important role in the forward march of evolution. The technical term of an evolutionary throwback is an atavism, from the Latin atavos, meaning forefather. The word has ugly connotations thanks largely to Cesare Lombroso, a 19th century Italian medic who argued that criminals were born, not made, and could be identified by certain physical features that were throwbacks to a primitive subhuman state. Nothing here, actually. While Lombroso was measuring criminals, a Belgian paleontologist called Luis Dolo, okay, ring a bell. Luis Dolo was studying fossil records and coming to the opposite conclusion. Opposite views, opposite conclusion. Be careful. In 1890, let me hear actually this opposite conclusion. Opposite views on evolutionary throwbacks are represented by Luis Dolo. Okay, so here it says that Dolo's finding and the conviction held by Lombroso was talking about Lombroso. Okay, so this is the answer for these questions. Just mention these two names. And of course, 33 is actually option G. And I'm going to highlight this one to do not look at it again. And because here mentioned Luis Dolo, I have this suspicion that maybe I'm going to find the answer for this question, 27 as well. When discussing the theory developed by Luis Dolo, the writer says that, okay, in 1890, he proposed that evolution was irreversible, that an organism is unable to return, even partially, to a previous stage already realized in the ranks of its ancestors. Early 20th century biologists came to a similar conclusion. Okay, Now here it says that it was immediately referred to as Dollo's law. No, it supported the possibility of evolutionary throwbacks. Maybe it was modified by biologists in the early 20th century. Yes, of course. In the early, here it says early 20th century biologists came to similar conclusion. It means that it was modified by biologists in the early 20th century. So option C is the answer. Now, after that, I'm gonna highlight the keyword related to question 28. The humpback whale cut off Vancouver Island is mentioned because of what? Talking about a kind of whale, humpback whale. And here I had to actually highlight the keywords related to question 34. Examples of evolutionary throwbacks have led to. So examples of evolutionary humpback whale, again, Wagner, South American lizard, Bachia. These are the keywords that I'm going to take care of it. So they qualified it in terms of probability, stating that there is no reason why evolution cannot run backwards. It is just very unlikely. And so the idea of irreversibility in evolution stuck and came to be known as Dollo's law. If Dollo's law is right, atavisms should occur only very rarely, if at all. Yet almost since the idea took root, exceptions have been cropping up. In 1919, for example, a humpback whale, okay? So here is the answer for this question. With a pair of leg-like appendages over a meter long, complete with a full set of limb bones, was cut off Vancouver Island in Canada. Explorer Roy Charpent Andrews argued at the time that the whale must be a throwback to a land-living ancestor. I can see no other explanation, he wrote in 1921. So he was describing this humpback whale. What is it says? Because of the exceptional size of its body, the way it exemplifies Dollo's law, the amount of local controversy it caused, the reason given for its unusual features. What is it? Here it says that humpback whale with a pair of leg-like appendages over a meter long, complete with a full set of limb bones. Okay, here he was talking about its unusual features actually. And D is the right answer. The reason given for its unusual features. Again, moving forward to next question. 29. What is it said about silent genes? So silent genes, example of evolutionary, Wagner, South American lizard, Wagner, Bachia. Okay. Since then, so many other examples have been discovered that it no longer makes sense to say that evolution is as good as irreversible. Evolution is as good as irreversible. So, examples of evolutionary throwback have led to, let me just continue the passage, and this poses a puzzle. How can characteristics that disappeared millions of years ago suddenly reappear? This poses a puzzle. Poses a puzzle means poses a question. How can characteristics that disappeared millions of years ago suddenly reappear? Okay, so the question of how certain long-last traits could reappear. Traits means characteristics. Reappear, here reappear, okay? So, and question means puzzle. These are the corresponding vocabularies. So the answer here is actually option A. And I'm going to highlight this one to not look at it again. 35. The shark and killer whale are mentioned to exemplify what? Okay, moving back to the passage. We are actually here, I think, suddenly reappear. In 1994, Rudolf Ruff and colleagues at Indiana University in the USA decided to use genetics to put a number on the probability of evolution going into reverse. They reasoned that while some evolutionary changes involve the loss of genes and are therefore irreversible, others may be the result of genes being switched off. If these silent genes are somehow switched back on, they argued long-lasting traits could reappear. Okay, it's talking about silent genes. So now look at the question. What is it said about silent genes? Their numbers vary according to species. No. Ruff disagreed with the use of the term. No. They could lead to the reemergence of certain characteristics. It could be this one. They can have an unlimited lifespan. No. This one actually. Here it says reappear. Could reappear. Traits means characteristics. This is exactly the paraphrasing the question. So C, option C is the right answer. Now, next question. The writer mentions the mole salamander because, and again, be careful. Where are we in here? Shark and killer whale, Wagner and Wagner Bakia. Okay, so Ruff's team went on to calculate the likelihood of it happening. Silent genes accumulate random mutations, they reason, eventually rendering them useless. So how long can a gene survive in a species if it is no longer used? The team calculated that there is a good chance of silent genes surviving for up to 6 million years in at least a few individuals in a population, and that some might survive as long as 10 million years. In other words, drawbacks are possible, but only to the relatively recent evolutionary past. As a possible example, the team pointed to the mole salamanders. Mole salamanders. Okay, now be careful. This is answering this question. Of Mexico and California, like most amphibians, these begin life in a juvenile tadpole state. Then metamorphose into the adult form, except for one species, the axolotl, which famously lives its entire life as a juvenile. The simplest explanation for this is that the axolotl lineage alone lost the ability to metamorphose, while others retained it. From a detailed analysis of the salamander's family tree, however, it is clear that the other lineage evolved from an ancestor that itself had lost the ability to metamorphose. In other words, metamorphosis in more salamanders is an atavism. The salamander example fits with Ruff's 10 million year time frame. Okay, now here it says that it exemplifies what happens in the development of most amphibians. It suggested that Ruff theory is correct. I think this one is actually the correct answer. Here it says that the salamander example fits with Ruff's 10 million year time frame. Fits means is Ruff theory is correct actually. So question 30, option B is the right answer. Now highlight the keyword related to question 31. Which of the following does Wagner claim? Wagner. Wagner claim like this yes no not given questions, and we have left with this question as the shark and killer whale. Okay. More recently, however, examples have been reported that break the time limit, suggesting that silent genes may not be the whole story. In a paper published last year, biologist Gunther Wagner of Yale University reported some work on the evolutionary history of a group of South American lizards called Bachia. Many of these have minuscule limbs. Some look more like snakes than lizards, and a few have completely lost the toes and their hind limbs. Other species, however, sport up to tower toes on their hind limbs. The simplest explanation is that the toed limbs never lost their toes, but Wagner begs to differ. Okay, now let me just look at these questions. Wagner was the first person to do research on. We cannot said it cannot said anything about this one. Believes that Bacchia lizard with toes had toeless ancestors. Had toeless ancestors. So I couldn't find anything about that actually. Let me just moving on. The simple explanation is that the toed lynx never lost their toes, but Wagner begs to differ. According to his analysis of the Bacchia family tree, the toed species re-evolved toes from toeless ancestors. Yes, here it says that. What is more, digit loss and gain have occurred. Digit loss and gain have occurred on more than one occasion over tens of millions of years. So, here it says Wagner believes that Bacchia lizard with toes had toeless ancestors. Yes. And here nothing about the first person to do research not given. So, and this question actually, which of the following does Wagner claim a member of the Bacchia lizard family have lost and regained? Here digit loss and gain have occurred. Regained certain features several times. On occasion, more than one occasion means several times over the tens of millions of years. They're exactly paraphrasing this statement. So statement A is true actually. Option A for 31. Now we have left with questions 35 and 36 and 39 and 40. Okay. The keywords for this question: the temporary occurrence of long-lasting traits in embryos, evolution drawbacks might be caused by development problems in the womb. So these are the keywords for this one. And for this one, actually, one explanation for the findings of Wagner's research. Findings of Wagner's research. One explanation. Okay. So what's going on? One possibility is that these traits are lost and then simplify reappear in much the same way that similar structures can independently arise in unrelated species, such as the dorsal fins of sharks and killer whales. Sharks and killer whales. This is the answer for question 35. Mentioned to exemplify what? Exemplify, let me just, in much the same way, the similar structures can independently arise in unrelated species, such as the dorsal fins of sharks and killer whales. Exemplify what? B. The occurrence of a particular feature in different species. Different species means unrelated species. Similar structure, occurrence of a particular feature, similar structures can independently arise in. Yes, of course. Option B is the right answer for this one. Again, paraphrasing the statement in here. You see, this maybe the most difficult task is to find where the answer is for this reading passage. So, another more intriguing possibility is that the genetic information needed to make toes somehow survived for tens or perhaps hundreds of millions of years in the lizards and was reactivated. So, these atavistic traits provided an advantage and spread through the population, effectively reversing evolution. One explanation for the findings of Wagner's research is parallels drawn between behavior and appearance, the continued existence of certain genetic information the doubts felt about evolutionary drawbacks. No. Let me just think about it. Here it says that another more intriguing possibility is that the genetic information needed to make toes somehow survived. Genetic information survived for tens or perhaps hundreds of million years in the lizard and was reactivated. So here it says that the continued existence of certain genetic information. Yes, of course. This is actually the right answer for this one. So 36 is option D actually. So we have left with just two questions. Be careful about embryos and womb. But if silent genes degrade within 6 to 10 million years, how can long-last traits be reactivated over longer timescales? The answer may lie in the womb. So here it says that evolutionary drawbacks might be caused by developmental problems in the womb. And here it says that if silent genes degrade within 6 to 10 million years, how can long-last traits be reactivated over longer time scales? The answer may lie in the womb. So here it says this one, yes, exactly the same statement. And early embryos, the temporary occurrence of long-last traits in embryos is rare. Early embryos of many species develop ancestral features. But here it says many species, here it says rare. This is completely the opposite. So the answer here is no, actually. So here are the answers for all of these questions. I hope you like this video. It's kind of a actually a hard passage to answer. This is from Cambridge IELTS book 10. I hope you guys can make this feeling that you can answer it if you know the paraphrasing, if you know how to actually find where the answer is. I'm just like you guys. I'm just a student just like you guys and try to share my experiences. Maybe I could help you, I could aid you to level up somehow a little bit. I hope you guys like it, and if that's the case, please give me a thumbs up and share this video with your friend. And if you're new here, hit that subscribe button and also the links on the description below. Thanks for watching.